there, everybody. Today we're going to do our first set of notes together, and our very first learning target is learning target 1.1, which is translating words into expressions and vice versa. And you have probably seen much of this before, so some of it will probably be review. A few of the words or phrases might be new to you. So we're going to go through them together and talk about how to turn words into expressions. So first thing you can see on this table that we have addition, subtraction, multiplication, division, powers, and equals. And each one of those operations has words that goes with it. I'm going to zoom in on this a little bit. And we're going to talk first about addition. So I think pretty much everybody knows that when you see plus, that means to add. So when you have a number plus 3, you're going to be doing something plus 3. Now the question is, when it says a number, what does that mean? If they don't tell you the number, you have to put something to put as a placeholder for the number that you don't know. And hopefully you remember that when you don't know a number, you use a variable. And a variable is a letter. So we can pick any letter. We're going to go ahead and pick X just because it's the most typical one. So if you see a number plus 3, that looks like X plus 3. Pretty easy, right? Sum is the answer to an addition problem. So if they say the sum of a number, I see we have a little typo right here, the sum of a number and 5. So here's the number plus, because it's the sum, 5, X plus 5. Total, if I said that I had $2 and you had $2, what's the total? We would add them together. So total means add. The total of 6 and a number means you would put 6 plus X. Notice on all 3 of these items, I'm doing the number and the variable in order. A number plus 3, X plus 3. A number and 5, X plus 5. 6 and a number, 6 plus X, okay? The same thing is going to happen when we do increased by. Thinking about the word increase, if you increase something, it gets higher. In order to get higher, you have to add. So we have a number increased by 2, X plus 2, okay? Hopefully those have been pretty simple. When we get to the bottom 2, we have to think for a second about what we're doing. Added to, this has even the word add in it. More than, I think you guys know to add. But when we look at the actual example, we have to think about the order that it's in. If I say 11 added to a number, which one am I starting with? Am I starting with 11 and adding the number, or am I starting with the number and adding 11? If 11 is being added, that means the number must be the thing I'm starting with, and it has to come first. Okay? Same thing with more than. If it's 10 more than a number, well, which one comes first? Do I have 10 and I'm adding the number, or do I have the number and I'm adding 10? If it's 10 more than, that means I'm starting with the number and adding 10. So for these two, I'm going to change colors here. For these two, we have to remember to reverse. And I'm going to write, hopefully right here without getting all over the screen, reverse. So we're going to flip the order of the items, okay? Those are all of the addition problems. Let's go down and talk about subtraction now. And I think I'm going to switch colors again. This time I'll go to green. All right, so minus, pretty much everybody knows that minus is subtraction. A number minus 7, X minus 7. Difference is the answer to a subtraction problem. So the difference of a number and 3 means X minus 3. Now, be very careful about this one that says less. You guys are probably used to seeing less than. That's something different. If it just says less, 9 less a number means go in order. 9 minus X, okay? Decreased by, that's the opposite of increased. If something is decreased, it's getting smaller. So a number decreased by 12, x minus 12. Here we come to our two that we need to worry about reversing. Less than and subtracted from. Just like more than and added to, okay? 4 less than a number. Well, in order to figure out what the answer is, I have to know what the number is first so I can take away 4. X minus 4. 4 less than means I have to start with the number. 6 subtracted from a number. That means we're starting with the number and we're taking 6 away from it, all right? So these are the two that we're going to be thinking about reversing. And addition and subtraction are pretty much the only ones that you have to worry about reversing. Just those two, okay? So we've got some tricky ones there. Added to, more than, less than, and subtracted from. All the rest go in order. Let's talk now about multiplication. I need a new color, and we're going to talk about the words that we have here. Everybody knows times, so 8 times a number means 8 times a number. Now, instead of writing 8 times x, we could just write 8x. Remember that a number and a letter right next to each other means multiplication. Product is the answer to a multiplication problem. So when you see product, you would be like, oh, okay, those are multiplied. The product of 14 and a number, 14 times x, which would be 14x. Twice or doubled means you're multiplying by 2. So twice a number, double a number, same thing, okay? Multiply by means multiply. So a number multiplied by -6. So this would be a number multiplied by -6. Now, when we put numbers and letters together, we always put the number first. That's called the coefficient. The number always goes first. So in this case, we would reverse the 2. Of means multiplication. A lot of kids don't know that. Whenever you see, like, for example, 3/4 of a number, that means to multiply. 3/4 of a number. And since it's a number and a letter, we can just write them together like this, 3/4 x. Okay? And there is your multiplication. Let's look at division. There's not too many ways to talk about division. I'll get a new color. We'll go with blue. Quotient. Quotient is the answer to a division problem. So the quotient of a number and 7. Now there's a couple different ways to write this. We can say, okay, a number and 7. There's the quotient of a number and 7. We do go in order, so the variable would come first and then the number would come second. Or we could write it as a fraction, okay? Division is the same thing as a fraction, so we would put x divided by 7. We could write it like that. Divided by is pretty obvious. 10 divided by a number. You could say 10 divided by a number, or you could do 10 divided by a number like this. Ratio also stands for division. So the ratio of a number and 15. So the number and 15 with division, or you could write it like this. The first number, whatever the first thing is, goes in the numerator. Okay? And then the other thing goes in the denominator. And there's division. Let's talk about powers. So powers are the same thing as exponents. And the most common ones that we'll be using probably are squared and cubed. So you probably already know that when you're squaring, you use an exponent of 2. So the square of a number would be x squared. If it says a number squared, same thing. But you may not know what cube is. The cube of a number means the power of 3. The reason is because squares are a 2-dimensional figure. So square is an exponent of 2. A cube is a 3-dimensional figure. So it gets an exponent of 3. So the cube of a number, x cubed. An exponent of 3 we call cubed. a number cubed, x cubed. And those are your exponents. Finally, we have all the different ways that you can say equals. Who knew, right, that there were so many ways to say equals? Obviously, there's the word itself. Is the same as, yields, and amounts to. So these examples sort of mix up everything that we've seen so far plus equals, and we can make actual equations. So 7 less than, this is supposed to be an n, 7 less than a number. So remember, if it's less than, you have to reverse it, equals 10. There you go. 7 less than a number equals 10. 3 times a number is -6. 8 is the same as, twice a number. There you go. 12 added to a number. So remember, this is one where you have to reverse it. If you weren't sure, you could look back at the top. 12 added to a number yields 5. And our last one, 9 less a number. So this one doesn't have the than, so you can go in order. 9 less a number amounts to 20. And there you go. There's all the zillions of ways that you can turn expressions into equations.